Thank you for joining us for today's Mainframe Virtual User Group. We're here today to talk about CICS. My name is Amanda Henley. I'm the managing editor at Planet Mainframe and your host for today's session. For today, I want to thank our partners, Broadcom and Data Kinetics, for their sponsorship of the virtual user groups. If you're not familiar with the virtual user groups or this is your first one, we also have sessions on IMS and DB2, and we are typically meeting every 60 days throughout the year. So I hope you'll join us for future events. This month at Planet Mainframe, we're talking about observability. So starting, I believe, today or tomorrow, and all month long, you'll get full feature pieces about observability on the mainframe. And all of that content will come to you for free on planetmainframe.com. There's also next month, we're going to talk about security, and then we'll be talking about AI in November. If you've got any interest in writing on those topics, you can reach out to me at ahenley@planetmainframe.com or through the site. We'd love to read it. We're an open publication, so you submit, we review, and we consider it for publication. Today, before we get started, I just want to let you know that our speakers are going to take Q&A as we go and then reserve some time at the end for additional questions. So if you've got a question, you can pop it in chat. I would encourage you, if if you need to further clarify your question, you can come off mute and do that. We'll try to take questions throughout. There will be time reserved at the end, so you can think about your questions along the way or just bring them to us at any time. And now we're ready to get started. So let me stop my screen share if I can find my button to do that. And we have 4 speakers for you today. So first up, well, let me go ahead and tell you who they are. We've got Todd Gagle, who's Distinguished Engineer at Broadcom, Mark Fokker, Senior Product Manager for CICS TS at IBM, Dave Dalton, Program Director at IBM Z Software Product Management, Makendra Nali, all right, Principal Software Architect for Broadcom. And we're talking about power of CICS, traces, and metrics. So first I want to invite Mark to share his screen. He's going to kick us off today.
Yeah, hi Amanda, and hello everybody. Yeah, great. Thank you for inviting us onto this virtual user group meeting. My name is Mark Fokker. I'm the Senior Product Manager for CICS TS. I've been working in CICS for over 30 years now, and working in various different roles in development, service, on strategy teams, and more recently in product management. So I've been very much involved in all of our sort of version 6 releases. And I'm also joined today by Dave Dalton, who's my manager, and he's going to chip in every now and again with some thoughts and maybe help with some Q&A later as well. So Amanda mentioned a number of topics that the user group is focusing on. So observability is one we're talking about today, but she did touch on security and AI, I heard. So funnily enough, CICS is very much in that space at the moment. So what I'm going to talk today about is some of the new capability we've got in CICS Transaction Server version 6.3. And before I get into the very latest release, I just thought I'd perhaps remind people that version 6 now is been out. 6.1 has been out since June 2022. Then we had 6.2 in June 2024. And then we just last Friday, we made CICS 6.3 available. So this is the 3rd release in our version. And across that version, these are the sorts of areas we've been focusing on. If you're sort of very much into CICS, if perhaps you're a CICS systems programmer, you're probably very familiar with these different areas. So we've been focusing on reduced cost of management and resiliency, And there's a number of technologies we've been looking at. Obviously, today we're going to be talking about open telemetry, but we've been doing a lot around optimizing how applications can be thread safe in CICS to access things like data tables and so on, and do that simultaneously to take advantage of these more powerful Z boxes with more processing power, more chips available to run simultaneous workloads. We've been reducing things like how we work with SMF to reduce the data and the volumes of that data that we write there, to give you all the same reporting and stats that you're used to, but doing it in a more optimized fashion to allow you to switch on perhaps more monitoring records and more useful data, because you can do that at scale now. We've also been looking at how we simplify sort of and automate routine work with CICS. So we've been contributing into the Ansible collection. We've been working over several releases actually to provide more and more policies actually as part of the product than having you to use perhaps automation software, perhaps key on certain CICS messages or combinations of events that are going on. That can be done in many cases more efficiently using CICS policies. So we've been broadening out the capability there. So that's complemented really by our focus also in security and compliance management. And this is really around helping both the security and CICS admins understand their security stance, be able to use information from the runtime and your security database, combining that with some tooling to allow you to understand what sort of transactions and resources are authorized for which users to use. Perhaps to understand that in the past, you may have that information ordered in a way that is difficult to manage just simply because you've authorized users instead of roles, for example. And we provide some great tooling now to allow you to understand that and improve it, as well as the security around communications with ATTLS and combinations of ZOS health checks, so you can understand how your system is meeting best practice, and then wrapping all that up really with information that we put out into SMF that's picked up by the Z Security Compliance Center, which is an IBM product to help auditors understand across the whole Z environment how they are meeting their sort of audit requirements for their different compliance requirements. So that's also complemented by a focus on developer productivity. And here we're really looking at enabling developers, especially new tenure developers who are familiar with tooling and languages that are more popular in the education space, and also open source software that may be useful to bring on onto the mainframe as a kind of framework to allow developers to be very productive, together with actually looking at languages like Java, which obviously encourage write once, run everywhere. So being able to port code and run that in the best place. So, for example, if microservices are accessing a lot of data in CICS, it may make sense to host some of those microservices close to the data. So if they got very chatty, sort of interactive communication with data, and that data is local to them, they can perform faster. And then lastly, around our increased business agility. So CICS as a middleware is very much involved in bringing a lot of pieces together for an overall application that's running on the mainframe. So whether that's messaging, whether it's API services, whether it's access to structured data like VSAM or DB2 or IMS, or perhaps even unstructured data living in some of those environments as well. And then wrapping all that up with modernizing applications as well. So across the whole sort of CICS version 6 platform, version 6.3 is building on a lot of things. So if you're on an older release, I do encourage you to look at version 6. So if we move on to what's new in 6.3. So as I mentioned, we just GA'd last week. Some of you have been on this journey with us, and thank you if you have and contributed your ideas, and if you've been participating in the CICS Design Partnership and the Open Beta, and perhaps you're a vendor as well and participating, taking our betas and testing and so on. I do thank you for joining us on that journey. And if you've not, look forward to the next journey. We're not quite started our next Open Beta, but watch this space in the next few months. We'll be going around that cycle again. So with 6.3 then, obviously today's particular focus is on open telemetry, and I'm going to talk in detail on how CICS supports that. But just as a summary, open telemetry is very much that sort of use case, which can be very powerful because it's not just one product and one set of use cases we're talking about here. We're saying that observability in general on Z is being greatly improved by the fact that CICS, as well as other subsystems, can all contribute into this ecosystem around open telemetry. So we'll talk about what that is, what it means for CICS, and how that is built on by other products to produce dashboards and so on to help site reliability engineers. So I'll touch on these other areas, and then in essence I'll summarize some of those use cases because I think that's kind of brings some of this to life a bit more, with our day-to-day jobs and how it can be useful. So I'll touch on some of these others in more detail, and then if you have any questions on these other areas that we're not talking about today, I'm happy to take questions later on or via the chat as well. So I'll touch on modernization then. So here within 6.3, we've been looking at VS Code as a development platform, as a choice for perhaps new tenure developers. And the kind of environment they're coming from is probably one where they're using VS Code in other companies or in their degree courses or wherever they're training. So they're probably familiar already with the basics of what VS Code is, how all the extensions work, how they can be combined together to provide that sweet spot where a developer can be very productive with the types of things, whether it's a front-end developer, whether it's API development, or indeed, writing different languages as well. And IBM has, if you like, providing a set of extensions for VS Code, which focus on the development languages that are particularly popular on ZOS. So there's an IBM Z Open Editor, which provides support for things like COBOL, PL1, JCL, Rex, etc. And one of those, when you're writing in those languages like COBOL and PL1, and writing a CICS application in particular, you're going to use CICS APIs. So the Z Open Editor, when you're editing COBOL, supports all the syntax highlighting, code completion, templating, and there's another extension, IBM Z Open Debug, and that similarly supports, not just the editing, but the whole debug lifecycle to, add breakpoints, step through your code, all that kind of stuff. And in addition, there are some editors provided by IBM Red Hat to support YAML editing, and we've been doing some particular work there around helping developers support config as code scenarios where they are not only writing their source code, but they may be describing the resources in CICS that are edited and managed alongside that source code. So as a package, we're looking at that whole VS Code experience from sort of editing, interacting with the mainframe using the Zoe extensions, as well as debug, as well as managing resources. So we're looking at that holistic experience and contributing to these different extensions. So the CICS team is, working with the Zoe teams and across IBM products to enable that. So you're probably familiar with IBM Developer for Z as an editor, and that is Eclipse-based. And in essence, you can use the same IDZ license that you have for Eclipse today, and you can get support for a VS Code as well. So developers can have, a choice as to where they develop based on their experience and what they're trying to achieve. On the AI front, we're starting in a journey with CICS to really contribute into the agentic AI framework that you may be familiar with. And in summary, there's different types of AI. There's a sort of generative AI, which is, creating pictures and summarizing text and so on. But what we're talking about here is when you have agents, which may be, trying to generate some text or do some analysis, there's a sort of learned corpus that these AI models, training models have, and that is very static. So that's understanding, for example, what is CICS. But then there's another side to AI, which is trying to get information from the runtime. And so that's what we're doing in 6.3 here, is providing an endpoint for AI agentic flows to connect in to the CICS runtime and inquire on information about transactions and the workloads that are going on in CICS. So it's a very gentle start. It's read only. You're not going to be able to tell AI to just fix all my CICS problems and it'll just magically know what to do. That may come in the future, but for the moment, this is just a gentle, route to allow more sophisticated AI agents that IBM's working on in the future. But this is going to get raw information from your CICS runtime to present as what's referred to as an AI tool for those agentic flows. So this is a gentle start. It runs in the CMCI JVM server. It's enabled by default. And we're hoping that customers are really going to start to see some value in this area, towards the end of this year. And IBM's got some announcements coming up. On the core side, CICS is obviously supporting very large workloads. Customers, are based their core business applications on it. And that means inevitably there's, quite a sizable amount of work we do every release to improve the CICS runtime for those core workloads. However, there's one particular area that we're trying to focus on here, and that's around CICS configuration, which for many years has grown up to, if you like, have different styles of ways of configuring CICS. So for example, in the past, you could take a CICS systems initialization parameters, and you can compile those into a table. You can put them in line. Today, you have various options and configuration on the ZFS file system. So things like resource overrides, and other things related to JVM servers and WS bind files, etc. So when you look at the CICS way of being configured, we think we can do a good job now at starting to draw those things together and simplify them into a standard that many people use today for configuration, which is around YAML. So we're providing a new configuration tool, and it's available in beta. It's not GA yet. We're still working on onboarding experiences and other aspects to that. So look forward to the GA of that, in the coming months. But for the moment, we have this ability to bring quite a few of the parameters together, and we're going to build on that in those coming months. We've been doing some additional enhancements around policies, and in particular around managing JVM servers and APC connections. On the security side, in 6.3, we're building on the concepts around zero trust, and we've been fine-tuning the experience in the tooling, which is in CICS Explorer. In particular, we've got some great enhancements there around providing a to-do list. So when you import your captured security information, which we introduced in 6.2, when you import that into the tooling and you import your RACF definitions into the tooling, we can provide some analysis and kind of best practice on where we think you can improve how your resources are secured in the RACF database. So we can, prompt you where perhaps you should be using roles rather than giving particular users access. Things like universal access can be fairly dangerous. So we can point out, scenarios, and there's a to-do list of, I think there's about 5 or 10 different areas that we can provide some guidance on. And the tooling sort of guides you through it as well. It's not just dumping you into, a lot of complicated data. It does guide you through how to sort of change that over time. So the other thing to point out there is that tooling can actually be used in lower releases. So if you just order CICS 6.3 or 6.2, in fact, you can use some of the JCL that we provide just in the installation, and you can export information from RACF and start to use that tooling. So you don't have to actually be using CICS in production to take advantage of some of that. And the last point I'll mention here is around our support for modern languages, in particular Java. So we've been doing a lot of work to make sure we keep up with the industry standards. And the value there is really to allow developers to bring their skills, their open API framework, their open source frameworks that they're used to using on other platforms, and allow them to use that in CICS. So things like Jakarta, Spring Boot are particular popular frameworks that we want to be able to support. So supporting the latest versions of those is important. It gives developers a lot more freedom of movement in how they can bring their skills and obviously write applications for CICS efficiently. So in a one-page kind of summary, that's where we are with 6.3. So what I was going to do now is to just touch on a couple of things. One is I mentioned a sort of set of use cases. So I'll perhaps leave you to ponder on this information after this session. But what I'm just trying to do here is trying to bring it to life for our different developers in what they can do, and systems programmers and so on. So I'll leave you to read that afterwards. So I'll just touch on upgrading a bit, just because some people think upgrading CICS is scary. It takes a long time, needs months of planning, and indeed, for those who've not done it before, I sympathize. CICS is a complex product, and it's important to get the upgrade right. But just to point out, there is a lot of opportunity to save costs, time by upgrading. using some of the features I've just talked about. We do believe that we're, as a product, delivering more value for your business, but that generally that also means you need to be on reasonably recent versions of the product. We do continuous delivery of providing new features on lower releases, but that can be very hard to do at times. So generally, being on the latest release means you're on the best opportunity for your business to actually take advantage of new features. I've mentioned some of the software and hardware prereqs there. So it's also worth pointing out you can upgrade directly from any previous release. So you don't have to be on 6.2 or anything. You can go directly from, say, 5.6 and directly up to 6.3. And on the prereq side, just bear in mind, if you're wanting to use OpenTelemetry, which we're about to dive into, you're going to need z/OS 3.1. And if you're using combinations of products with CICS, for example, MQ, and you want to have MQ emit OpenTelemetry, you'll need to upgrade MQ. Similarly, if you're using the Transaction Gateway or z/OS Connect, or other products like DB2, they'll need upgrading. If you want to have those products emit OpenTelemetry, or indeed, as we'll talk about, in order to propagate information into CICS, it may be necessary to upgrade those products to make sure that OpenTelemetry data actually flows into the CICS environment in the first place. Okay, so this is just a kind of useful timeline. So you're probably aware of which release you're using and when they were made available, and more particular when they're going to be end of service. So I'll just point out we've not announced the end of service of CICS 5.6, but for planning purposes, I would suggest you anticipate that's going to be in 2026. Excuse me, 2027, first half, roughly. So if you're on that release, do look at upgrading, and to 6.3 would be great. Okay, so I'll touch on OpenTelemetry in more detail now. I apologize if you've got this far and are unfamiliar with what OpenTelemetry is. I've sort of made that assumption, but I'll just outline it here. So it's a vendor agnostic observability framework. So what that means is, if you're wanting to look at workload as it's running across different runtimes, so and maybe even different platforms, different products are involved. There are sort of two, if you like, different styles of approach. One is that a vendor provides a very specific product to do that, and they provide hooks or user exits or whatever you want to call them in a whole plethora of other products, and then says, if you use our tool as an observability framework, you then install all these exits in these other products, and then all the data can flow into our product, and we can show you a dashboard with all this observing the workload. But the problem there is, can that vendor keep up? Can they support all the versions and the products you're using? You may well be then locked into that solution for some time, because having a view across all your environments is very important and valuable. Another approach is to use the OpenTelemetry framework, which is, as it says, it's vendor agnostic. So this is where a group of people have come together as an open source initiative. They've got implementation that you can use out of the box on many different environments. So, Java runtimes, Node runtimes, etc., have inbuilt support for OpenTelemetry, or they've got an SDK or some sort of injection process to allow that to work. So Yeah, so by being sort of agnostic, the idea is various different applications can be instrumented using this combination of either explicit APIs or SDKs. In many cases, they're provided for that environment already, and then code can either take advantage of them or they can be automatically instrumented. And then when the data flows from that application about what's going on in that environment, there's a set of protocols, OpenTelemetry standard protocols that can allow that to flow to a set of processes called the collectors, and they can receive, process, and then export, i.e. do things like filtering, for example. And then once that collection process has happened, the OpenTelemetry data can then flow to back-end environments. And there's a choice of environments, from different vendors. And there's, open source implementations as well, like Jaeger. That's certainly within CICS we've been playing around with as well. So that's what OpenTelemetry is. So, the next question really is, maybe an example helps to put this to life. So you can imagine here, you may have a sort of shopping cart sort of scenario where you're using a combination of, web applications which call, API services out in the cloud. Maybe that, flows through to Linux environments, maybe ends up on an MQ message, which then ends up driving a CICS transaction and updating DB2. So, by using OpenTelemetry, we can get a full view of this kind of application. So yes, so why would you actually need observability anyway? So, the typical use case is around isolating problems. So just understanding the flows through your different environments for a particular application has value in itself, right? Because otherwise it's a matter of people understanding their bit of the puzzle, but struggling to understand how that connects with other components. And in the past, we'd have things like architects who would have that more overarching view of how things should work. But when reality bites, having things like actual instrumentation of that workload flowing through to help isolate problems and identify, actually which bits are talking, which components are talking to other components, has a lot of value. So that's what really OpenTelemetry is around. It's about understanding how the workload flows and then isolating problems when they happen, and doing that in a sort of consistent manner. So you do have a bigger picture. So that's really so. Also, many companies have what's referred to here on the chart as a site reliability engineer, so an SRE, and that role can then be responsible for, once all the data flows into observability frameworks and dashboards, that role can then bring that understanding onto one pane of glass, and then can write automation and management and monitoring of that whole end-to-end picture. So you can get early insights as to when there are problems and actually potentially fix things before actually anybody's noticed. That's the kind of panacea that people are aiming towards. So, this is just bringing it all together on one picture, really. So the other item that's mentioned on here is the fact that the CICS is doing this in a zero code solution. So I mentioned other environments like Java have things like SDK, so you can take an application that has no knowledge of OpenTelemetry, and you can basically inject the SDK into that environment, and you can instrument, when certain method calls are made in the application, and extract data from that to understand how that workload is running. And similarly, CICS in the 6.3 product has this zero code solution. So you don't need to change one line of code within your applications. You can simply upgrade to CICS 6.3. You can install, the right components on ZOS and configure the CICS transaction and the CICS region to process the OpenTelemetry, and we'll talk about how to do that in a minute. So you can select, I want these transactions to be emitting OpenTelemetry trace, and CICS will start doing that. There's no need or disruption to your application, and so from that point of view, you can get the value out of this, very, very quickly. You don't need to retest your application. Your application behavior is not going to change. Even if there's a failure to emit the OpenTelemetry data, your application will just carry on. So from that point of view, this is great. One of those great features where you can just upgrade and start to get value from it very quickly, especially if your company is already using OpenTelemetry. So you can imagine a dashboard then, which is, bringing these things together. So, across the top of the, different components, emitting OpenTelemetry, and then using dashboards, that OpenTelemetry trace finds its way to the back end that I mentioned before. And then you can draw, graphs, timelined graphs that say, the workload, what's referred to here as a span, which is a time period. The workload is happening on these different environments for certain time periods, and so it will show in a graph, manner when those start and stopped, and which spans ended up resulting, in child spans being created in different environments. So you can see the sort of hierarchy going down the graph, and you can see the time span going across the graph. So you can see the relationship between these, and then you can, hover over these spans and get information about what happened in that environment. Did the CICS application append? When did it start? When did it end? What was the task number? Which CICS region did it run under? Which LPAR was it running in? Those sorts of things. Okay, this slide is really just enumerating that. So, there are some basic information that's in there, mandatory, like the start and end time, what type of span it is, etc. And then there are product-specific things. So in this slide, on the right-hand side, you can see the mandatory and some of the optional things that we put in. So you can see here there's things like the client port, the client IP address, what facility type is it? So did it come across IPIC? Was it across MRO? That sort of thing. What program name was the initial program that handled this transaction? The CICS region, Apple ID name, system name, etc. All useful information to know, where did this run? What happened? Now, it may be worth bearing in mind, this is not designed to allow you to fully diagnose the problem. This is to allow you to identify what happened and where it happened, and to give you enough connection points or hooks, if you like, to be able to use your existing tooling to then diagnose what the actual, so what we're looking at here is, if you like, the symptom, right? This application may have appended, but it doesn't say necessarily why it appended. It may have been short on storage or whatever. So the append code will be in here, but it won't say this line of code caused the problem. We expect you to use this information to index into those other SME tools. This just gives you a view of some of the protocols that we're supporting. I think it's fair to say we're supporting pretty much the majority of CICS interaction patterns. There are a few esoteric ones which some of our customers use, like APPC, that we're going to be looking into next. But otherwise, we've pretty much fully covered all of, well, I would say the majority of the CICS interaction patterns. So, you know, you can, you're no doubt using the majority of these at any one point in time. And the CICS sort of ways of initiating work across these different protocols are handled in 6.3. So I'll just finish on a few slides which talk about configuration, because I think that may be interesting, especially if you're new to this area. So we have two sort of things to consider here. One is around the trace context propagation. So this is, will CICS receive and process OTel information from other third parties, if you like? And the other is when CICS, you know, propagates this open telemetry context out to other environments. So, for example, if we're going to write to DB2, do we want to pass the context on to DB2? And then there's the actual span emission. So if we are having OTel information propagated into CICS, do we want to actually emit a span record as a result of that task? So these are two separate configurations within CICS, because there may be scenarios where you want to just propagate information across a CICS region, but not actually emit things, because you may think there's, if you like, little value because things never go wrong. So an example is if you've got an environment like, for example, function shipping. So you've got a CICS region that's accepting function shipping commands. You may decide that it's not worth providing OTel information about workload in that address space, because that never goes wrong, and it's a level of detail you do not need to actually diagnose CICS problems. On the other hand, you may decide it absolutely is, because, you know, sometimes things go wrong because, I don't know, maybe a vSAM file is sometimes closed, so you do want to emit span information. So you may want to propagate and not emit. So we provide, you know, those two levels of configuration. So there's in essence two different places for this configuration. So there's a SIP parameter, which in essence says, do you want CICS to process OpenTelemetry trace or not? So that's a big switch at a SIP parameter level. The default is no. So when you upgrade, there's going to be sort of no automatic opting into this thing. So you will have to set it to yes if you want to process OpenTelemetry within CICS. And then there's SPI to be able to inquire on that, as you would expect. And then there's CICS transaction attributes, and there's two attributes. The first is about propagation, so OTel prop. And so you can choose to either propagate or not. So this is, do you want to propagate to downstream systems? So if the request came into CICS and say from ZOS Connect, it had OpenTelemetry, do you want to propagate it when you make an exec CICS link to a downstream CICS region or not? It may be a CICS region that is owned by a business partner and you do not want to propagate that information, in which case you can use no or no prop. But otherwise, you know, you would be encouraged to use prop only, and that would then propagate it to other environments. And then the other option I mentioned was then OpenTelemetry emit. And by setting that at task end, that means that at the end of the task that's processing the request, we will emit one OpenTelemetry span record for that task, summarizing how it, you know, when it started, when it ended, you know, did it append, and other information about, you know, its status to allow you, you know, to potentially follow up if there are problems. And then, of course, there's an inquire associated with that, so you can understand what those settings are. Okay, so this is really just summarizing the sort of use cases. So you can imagine if you're upgrading from a lower release of CICS, you would have the SIP parameter set as no, and you wouldn't get any open telemetry information processed in CICS. And then you may want to join a sort of corporate-wide open telemetry initiative, in which case you'd set open telemetry in the SIP parameter to be yes, and then you would select certain transactions that you want to, emit that you want to process as either a prop only or at a task end, perhaps, and that would fully enable those transactions to emit open telemetry records. And then there may be other scenarios where you sort of enable all your transactions or a large volume of them to be emitting open telemetry span records. But you could fine tune some of them to say, well, actually, these ones I want to emit at the task end, but I don't need to propagate it to another CICS region. And so you could fine tune which tasks do which. And the other thing to consider is if the sender of the open telemetry record decided it did not want to trace a particular record, it sets a sampled flag within the span context that's sent into CICS, and CICS will not generate an open telemetry span in that scenario. So this is what's referred to as sampling, and it can mean that the client can decide to sample, say, 1 in every 100 requests, it's going to sample into an environment. And that perhaps is a balance between, how much value you're getting out of these records and how much extra processing it's costing to create and store the open telemetry data in your backend for OTel. So it may also be if a system is running really well, really slickly, you have a very low sample rate. But if you're going to put a new version in, you set up, you increase the sampling frequency because you want to monitor it more closely to see if there are any problems, and then you back off the sampling, as you're rolling out application versions. So, there may well be a time when other people outside of Z are deciding the frequency at which the information is useful or not. And that's absolutely fine. That's the whole point of this is, there's no point having open telemetry spans for just parts of a workload. It's really useful when you have those records across all your different subsystems and aligned to particular, requests. So everyone should either produce open telemetry records or not. There's no point just having pockets. Otherwise, the information becomes a lot less useful. So this is really just to bring it all together in a sort of flow of what's happening. And that is, a client is sending in requests. It's submitting OTel spans to an OTel backend endpoint, maybe a Jaeger environment, for example. The CICS region itself is processing work, so it's initiating tasks. It's getting the OTel data in. So it's inheriting, if you like, the trace ID from the parent, which is the client in this case. And then it's creating OTel data, right? Because at the task end, it's going to want to emit a span record. And in this case, CICS is using SMF as a temporary mechanism to then send that data to a backend environment. And then a ZOS component referred to as ZOS data gatherer reads those records in from SMF and writes them out in a asynchronous way out to the OTel backend. And that means CICS can be fast and furious. It can get through the workload if there are failures in emitting and formatting or connecting to the OTel backend. in essence, that does not disrupt or affect the CICS workload. CICS has been working with SMF for many years, very efficiently. So the ZOS team know how to set up that environment, how to size it, etc., for appropriately for the workload. And this new component, the ZOS data, well, ZOS data gatherer is not new, but there's a new component within that, which then reads these SMF records and formats them out. And that, if you like, is done in a Java environment, and that can be obviously then processed on zip engines, which can be very efficiently, taking out some of the CPU consumption associated with, just writing out these records. So that way that the CICS workload is not affected from a performance and a response time point of view, but yet we get very valuable data out all into the OTel environment. So that's, I just add a last slide here on examples of sort of the span records that are written out. So this is like a screen capture from a Jaeger dashboard showing a different environment, different examples here about the types of attributes that are in those span records that allow you to understand, well, this was a particular request that was processed in CICS, and we've tried to keep these attributes to be both useful but not replicate things that you could find out elsewhere. So as I say, this is not designed to diagnose problems. This is designed to identify where work was run, when it started and finished, and if you like, its connection points to other things, but not to replace things like monitoring or statistics, or indeed more deeper diagnostic tools like dump analysis and so on. It's not designed to do that. So that was pretty much it. I just had repeated the slide that we saw before. So I'll just ask if there's any questions. If I stop sharing so we can go on to Todd's bit.
All right, thank you, Mark.
Okay.
I think Amanda's going to have to give me sharing privileges again.
Is it not letting you share? It says it should
It's
be.
not. I had a network connection and I had to rejoin, and I got a feeling it kicked some things out.
Let me okay.
It's either that or we can have Max share and I can
You
talk
should have
to
better
his.
access to share now if you'll try again.
All right, it looks like it, yeah. Okay, great. All right, let me get started then. So we're really going to continue on with what Mark has been talking about and really talk about the power of CICS traces, but we're going to expand that a little bit into the metrics and logs. And my name is Todd Gagle. I'm a distinguished engineer at Broadcom. I have been working in the software that's now owned by Broadcom and several other companies prior to that through mergers and acquisitions for the past 38 years. Very specifically, I've spent that entire career and several more working with CICS. I actually started with CICS MVS 1.6.0. So that's a long time ago. But very much enjoyed working with CICS all my life, and I've very much enjoyed working with the folks over in Hersley as well. So let's get started. So quick agenda slide here is what I really want to do is kind of give you an idea of what end-to-end tracing looks like today Then I want to show you what end-to-end tracing looks like in something I'm calling a coordinated effort. And then we'll give you a little bit of a peek at what I think maybe some system programmers tools might want to look like to get an idea of what's going on your system. And then Mac is going to take over and probably give you the most exciting part of ours, where he's going to actually demo the art of the possible. Okay, so in this particular case, what does end-to-end transaction tracing look like today? Well, as I'm saying here, it's by no means a new idea. People have been wanting to do this for decades. And everybody's had some kind of a solution to do it for decades. And when we talk about end-to-end transactions, typically people are talking about things that start off the platform or off the mainframe. Today they might be starting on your phone, or it might be starting at some kind of a banking application on the web. The important part of this that may not seem as hard as it is you have to be able to follow those transactions through several layers of hardware and components. It might start on your phone. How many hops through hardware does that transaction basically have to flow all the way into the mainframe and all the way back? And nobody can drop any data along the way, otherwise you get a black hole. People say that when their transactions run, it gets to the mainframe and now it's just a black hole. They know it went to the mainframe, but they can't see anything in the mainframe, so they refer to that as the black hole. So then I'll ask all of you, and you don't necessarily have to respond, but this seems to be a common procedure that happens, is when people are doing their transaction tracing or watching their networks, they're watching response times and they're seeing an application slow down. What happens in your shop when that occurs? Well, in many, you immediately get on this monster conference call with dozens, if not hundreds of people. And a lot of people refer to that as the war room. But what's the goal of every single one of you in that conference call? The first thing you want to do is, number one, everybody's pointing fingers in every direction. And the first thing you want to be able to do is say and prove that the transaction slowdown is not my problem. Why? Because you get to leave the call. So it's very important that you need tools then to be able to make that happen. So a little bit more. Several vendors have products today that can provide CICS tracing. The one problem, and Mark touched on this as well, tracing and correlation information and data that's being used today is extremely proprietary. So it doesn't work across vendors very well. It doesn't work across products very well. And the real problem with it, honestly, is the insertion of data and the propagation of data, of that correlation data, can be extremely difficult. Again, I talked about starting on your phone or on a website and it hops through multiple places. Remember, you have to get that correlation data inserted in some kind of a payload, send it to the next agent. It's going to have to pick that up and say, okay, I'm not going to lose this, and keep it going. Now, if any one of those hops, loses it, you're kind of done. You've created another black hole, but you're kind of done because it'll go black at that point. So that's really the big challenge. So at Broadcom, we do have a product called SysView, and we've got a product called DXAPM that between the two, they do provide transaction tracing today. And that actually does include correlation data in proprietary format, and we can accept OTel format, or internally, it's in a W3C format. And that kind of data has been around a long time. So if data is making its way through the network and it's in an OTel or W3C format, we can actually pick that information up, we can propagate that information across CICS regions, and it will propagate across all versions. And then that information is also recorded in the sysview for CICS transaction SMF records. So it does get logged. And then we've also got products that can actually correlate that data for you. So let's move on to, then what am I calling the coordinated effort? And this, do not underestimate or the value of this is the IBM subsystems, and we talked about that. It's the CICS, it's the MQ, it's DB2, IMS, ZOS Connect. They have all been enhanced or going to be enhanced where they are going to handle the extracting of that OTel information, the span information, or the trace IDs. And more importantly, they're going to do the propagation, right? That's because that still is the thing. You get the data in, you got to propagate it. One of the things, though, that it does require is that you do need the latest and greatest releases of each of those CICS, or not CICS, but IBM products to make it fully work across your LPAR or Sysplex. Hopefully, and I really encourage this is a huge benefit if you're working in this environment, that I'm hoping that people will adopt the newer releases more quickly or encourage upgrades, because it is well worth it. So again, IBM will take that data that comes in and propagate it of spans of data to other CICS regions and all the other subsystems, the MQs, the DB2s, etc. And the great thing is the same trace and span data is now going to be used everywhere. You're not getting a mixture of proprietary data. Everybody can play, and everybody can add data if they want to. Then what happens after that is that span data, of course, then has to be sent to an OTel collector of your choice so that it can do all the magical dashboards and graphing and all the things that are really pretty to look at. So the burden of collection has been removed, but the next thing is we need to focus on, it's easy to now collect the data, it's easy to propagate the data, it's easy to emit the data. The next big issue is going to be focused on how do we analyze the data, because the data is becoming a lot easier to get now, but the next thing to make this all fantastic is the analyzation of that data. So we also then said, well, we were talking about, we want to go beyond tracing. Tracing is going to tell you where that transaction made all of its hops. But when you're looking at it, it's going to tell you how long it was at each hop, but you might be able to get more information if you've got some logs and metrics. So we're going to examine that next. So I'm guessing many of you out there are system programmers, or maybe you're writing code. But as a system programmer or even a developer, you'd kind of like to see validation of activity that's running on your system. You'd like to better understand the data that's being produced, and it's always great to have a visualization of the data so that you can better understand it and say, oh, gee, I understand exactly what that is. So within sysview, we're going to give you an example of just, again, what's possible, and just provide some simple system programmer tools and have them run in your natural environment to kind of answer those questions. So as just some quick screenshots, really, this happens to be a command in sysview that is able to display a log of open telemetry records that were created. These are the actual SMF records that were emitted. Now, in the example that I have on the screen, we were testing an MQ and CICS type transaction. So you can see down here, you can see where the source was. It an MQ type source or a CICS? How long did it actually run? That's the service time. So you can tell where the hops were. And you got quite a bit of information going down the side. So on this next screen, though, I've singled out really what you might consider the transaction or the end-to-end transaction. and it really consisted, or 4 records got produced. In this particular case, MQ started it, where they actually did an MQ put onto a CICS queue. That CICS queue really ended up being a trigger queue. And then the CICS region, which we're going to be the second line down here, actually did the get off the M of the CICS queue, and then it started a transaction, in this case called SLP3. SLP3 finished up by issuing a put on the CICS reply queue. And that was the total of that end-to-end transaction. Now, the screen that I have here for you can scroll right and left. So the part down here on the bottom is really the data that's out to the right on these lines. And you'll notice we've been talking about trace IDs, span IDs, parent IDs, and you'll notice the trace ID in all these records are the same. And that says it participated in the same end-to-end transaction. Now, when you then get in there, is each record that's going to, or each subsystem or piece that's going to emit span data is going to generate a span for itself. And then you can also see who the parent was. So the parent here is kind of outside of our scope, but on the second line down, you can see here's the new span for the get of the queue, and its parent you can see goes back to this span ID, and so on and so forth. So you get an idea of what the data is that's flowing through your system, not just because even when it gets to your OTel collectors, it's great that it did it, but you probably have no visual reference of what actually happened or what these things look like. Mark did give you a couple little snapshots of what the data looks like, and I'm going to do the same thing. So within any of these records, we can actually format these records and show you exactly what's in them. So as he said, you get a start time and end time, which you can compute in elapsed time. What system did it run on? What subsystem did it start on? It's a server, which is its kind. You got your trace ID, span ID, parent ID, and then these are really kind of the keywords that are going to be sent on and interpreted as the OTel things, along with the values, as Mark also talked about. This is a short snippet, although in the CICS records, they really made an effort to keep this record, I think, fairly small. So it did not get filled up with lots and lots of data that you may not need, because you got to remember, this is an extra SMF record that's going to be cut for every transaction, and CICS already cuts quite a few. So I think they did a really good job on their goals here. Now, this next piece happens to be coming out of a SysView CICS transaction record that's created, but the same data would also be actually in your SMF 110 records, your performance records. So the thing to note that is in the SysView record and in the SMF 110 record is there is a new section of data that gets logged that will give you that trace ID, parent ID, or all the OTel span information. I copied this part here on the right, which is really just a look at what we refer to as degradation analysis, to say, in that OTel record, really the only thing you're getting that's metric oriented is pretty much how long did that span run? You might be thinking, well, gee, I might like to have some of this other stuff too, because that would tell me, maybe how much CPU time it ran, how long it spent in MQ, or how long it spent in DB2, something like that. That part's not there, and it's intentionally not there. But that's where I'm suggesting there's a future where maybe if you add metrics to that same OTel collector or logs, you can expand the future of this and get more information out of it. This next one here happens to be just a snippet here so I can show you what that same MQ record looked like. So it's going to be identical. It's just got different names and values in it. But for somebody that likes to be able to touch and feel and visualize, this is just a simple tool that you can see activity running through your system and get an idea of what's really going on. All right. So now I think this is where we should be pretty exciting. My good friend and colleague, Machindra, is going to give us a demo of really kind of what is the art of the possible when it comes to combining CICS traces, metrics, and logs.
All right, Todd, thank you very much for setting me up. Could you actually put back those slides, and then we have 2 more slides just to set up the demo?
You bet. I forgot about that.
No problem.
Okay.
All right. So before we jump onto the demo, let's actually define a couple of personas in there. We kind of think of 2 different types of personas. One persona, especially on the mainframe side, is the subject matter experts, like system programmers and system performance analyst, network admin and DB2s and system operators. There are so many personas out there who requires deep dive tools to look at the mainframe telemetry. And we do have a ton of tools out already there. Todd has been talking about the SysView, which can be used for the system monitoring and stuff. Whereas there is another set of persona, that's a site reliability engineer. And Todd, I don't see the picture. Can you click next? Oh, yes. And that's where today's focus is. So site reliability engineers are the one who are responsible for end-to-end visibility of the application health. Imagine that nowadays the applications are not completely deployed only and only on the mainframe. There are some parts which are running on the distributed side. Maybe it's on-prem, maybe it is in cloud, or you are making, say, know your customer calls to a third party, say, web services. So that means mainframe is not at the corner, but it is in the middle of all these interactions. So from the site reliability engineer's perspective, it's important that how that application is performing. What is the quality of service of your application to your customers, irrespective of the platform. So we kind of very excited with this CICS subsystem opening up the traces so that the platform and different subsystems such as CICS MQ becomes yet another platform that is observable with the modern tools that I'm using on the distributed side of the house. So for that, let's see how we're going to use it. So Todd, can you move to the next slide, please? So as Mark and Todd alluded already, that open telemetry is the standard that helps us to extract the telemetry from variety of your services, sub-services, different platforms in a standard format. And that format happens to be open telemetry. In this picture, really, you have so many different variety of services, including those which are running on the mainframe. Imagine CICS running on the mainframe is one more box into the game, all emitting open telemetry from different services, and we put them together into one enterprise tool that we can look at. So from the SRE perspective, I'm going to play a role of SRE, and from my perspective, most important part is to see the whole application end to end at one central place, and also quickly point out where the problem could be and engage that team for the deep dive. So for the deep dive, that team might go into the mainframe if the mainframe is the culprit, and they use the existing system monitoring tools for more diagnostic. But from my perspective, I'm responsible for the application health. Show me the health end to end for my application. With that thought, I'm going to share my screen and showcase one of the web application that I developed. I know it is poor user experience, but it gets the idea. This is the typical general app that we have. It's a web interface. You may be having your mobile app or web application running somewhere. But ultimately, for today's discussion, is making a call into the mainframe, into CICS, and run some CICS transactions. Now, this application is working fine so far, but imagine if the performance of this application goes down, or if it is not working at all, if it is not reliable, if it is not available, the whole problem comes down to, hey, where is the problem and whom should I engage to, right? So for that, as we have seen in the earlier pictures on the slide, that every service involved into my application is already emitting traces. So let's take a look at the traces. For that, I'm going to use any enterprise tool just for the sake of demonstration. And doesn't matter which enterprise tool that you may be using. But here is how the traces look like. There are various different ways the traces will be displayed based on what enterprise tool that you are using. But here you can see that I do have a ton of traces down here as we speak being collected into this particular tool. The chart it is showing is that how the response time of that particular transaction look like, and the green ones are the one that possibly are fine. There are no errors occurred during that transaction, but there could be a possibility that if you turn on the filter for error, you see that there are some transactions which did not go through well. So let's take a look at one of the trace. So I'm going to click on the trace, and that opens up a waterfall kind of a view. And now by just looking at this trace, you actually can tell that how this transaction executed from end to end. What does this mean? So this particular transaction is originated from the web, and it has made a call to the banking client, which is a gate call. It is also making another gate call, and eventually it landed into CICS. So that means irrespective of the platform, I could see the whole trace, the audit trail of the transaction, starting from the browser till it hit the CICS transaction on the mainframe. You can also notice that there are some like the response time for each operation that as it occurred is being also captured as part of the open telemetry trace. So it looks like 47, 48 milliseconds for each operation looks like a norm. And that's how you actually see the trace. Now, along with the trace, you will also encounter some situations where there are some errors along the way. Imagine that if the CICS transaction, if there is an abend, so you would like to know that, well, that CICS transaction has got the abend code and you want to drill down further down there, right? So hopefully you got an idea of what the trace mean and how it is being actually displayed. With that, I can actually take a look at one of the trace and see we can go into detail a little bit. I'm looking for some trace which is interesting enough for the demo. Give me a second because this is live, so new situation keeps happening. Okay. All right, so here is one CICS trace. The CWBA is the CICS transaction, and looks like there was an error, which is a log event, which is being captured here, saying that the CICS web interface detected error response from the business logic interface program, and here is the program name, DFH WBBLI. So decorating this kind of a log events along with the traces and decorating with the metrics, me as a SRE feels powerful because I get to see all the context about the transaction metrics. It also get the log events, I also get the traces, how they are being performed. Now that we looked at the traces, which is a primer, I'm gonna pull out a little bit and take a look at the service from the service point of view. So from CICS region perspective, I can now look at those traces and build this kind of a graphs automatically for me. So just by looking at this chart, I can know that, well, these are the number of requests coming in, and that is 4.5 requests per second is the rate, which is the transaction rate on the CICS region. And also take a look at another chart, which is telling me how many of these requests are failing. There may be an abend somewhere, so how many of them are failing? And the next chart is talking about the latency. How many of these CICS transactions are running with the response time high or low. And based on the latency, I know that, well, there is some latency increase at this particular moment. So I can drill down to that trace. I can drill down to that transaction and find out what's going on in there. So this way we can take a look at the granular level, also zoom out and take a look at the service level. So here is another way that these are all different CICS transactions. I know that on this demo system, not interesting transactions are running, but you can take a look at the particular CICS transaction and then drill down further and say what's going on. What is the latency for that transaction? What's the request? How many requests are coming in? Are there any events happening? Those kind of details can be found quickly. So in this particular CICS transaction, looks like some of them are not working well. So I can drill down further and take a look at the traces. And that opens up a new view. And this tells me that why this particular transaction did not work well and what was the error. Okay, so I'm going to go back here to the service level. Now imagine you are responsible as a SRE to upkeep this particular transaction. So you are responsible to ensure that this is working fine. You are not going to take a look at the traces every day and keep looking at the traces one after another. That's too much of information to get through it, right? So these are a ton of CICS transactions to look at. And then there should be a better way. And the better way would be, well, maybe I should have some mechanism to generate an alert if my expectation is not matched. So how do I do? Right? So for that to happen, I could actually build kind of an alerting on the top. So there are several ways that you can do alerting. You can do the alerting by taking the metrics, for example, CICS response time, maybe the transaction rate, maybe you look at the event rate, or if you take a look at some of the resource metrics, and then you can generate an alert on the top. But the better way from the SRE perspective is to generate something called SLO level alerts. So I have defined some SLO level alerts here for my service. So for the sake of audience, let me explain a little bit who are not familiar with this term called SLO. SLO are service level objectives. Those are the target reliability goal you commit to users. For example, in this case, my goal is 99.99%. So that's my target. But look at this banking client service. It is not matching up to my kind of a goal. So the SLO service balances the user experience or expectations with the engineering resources and should be slightly less aggressive than SLIs. And what is SLI? SLI is service level indicator. So let me show you SLO, SLI, and there is another word, another key term called error budget by drilling down into this banking client service. So here it says, hey, you are supposed to keep this banking client service to be 99.999%, but you're not, and that's why it is red. And that means you should stop developing the code and focusing on the stability and reliability of this particular service. Henceforth, you are in the minus error budget here. That means you ran out of what errors are allowed to be in your production. And henceforth, you should focus more on making the system reliable. So for that to happen, I want to know why this service is not keeping up with my SLO. And for that, I'm going to take a look at the bad events that happen. And those bad events, I can further drill down and take a look at the traces. And that brings up the trace view. And I can take a look at just error and click on one of them and take a look at what's going on. And in this case, it says, well, you did not match to your SLO because there are so many errors happening. I drill down to the error And now I'm drill down and finding out why the error is happening. And turn out to be on the CICS, on the mainframe side, looks like the distributed side is fine. But for the mainframe side, there are some errors which are happening that I should take a look at it. And this way, I go fix this particular problem, and henceforth the errors will be lessened. Henceforth, I will be within my SLO, and henceforth I match to my expectations. And that's how probably we would actually use these traces coming out of CICS subsystem in a larger context. I spoke a lot. I need a pause. Do you have any questions and comments so far? Am I making sense? I mean, I'm not sure whether audience can unmute themselves and then ask the question.
They can. I was just about to suggest that if you have questions or comments or want to see something in, you can absolutely come off mute.
I will give a pause of 10 seconds and see if we have any questions. So let me ask you a different question, maybe easy one. So far, whatever I demonstrated with the CICS traces, does it resonate with you? Does it make sense? Looks like our audience is shy today, so I'll move on. Along with the traces, you may like to actually bring in the metrics as well. Traces tells you where the problem is. Traces also tells you what's the latency looks like, what's the bend rate look like, what's the audit trail of that transaction look like, and whom to involve in diagnosing that issue. You may like to also take advantage of your existing monitors to marry this with the metrics. So what I'm showing you is ton of metrics that we collect already with the existing monitors, which could also be looked at when you want to diagnose this problem. So here is a sample dashboard, which is showing you the key performance indicators of your CICS to be looked at, and you can deep dive into those charts. So that's about it. Just to wrap up, you would like to actually take advantage of the open standards such as open telemetry, baking into your existing services on the distributed side. But the good news is that now the CICS is also exporting the traces, doing the heavy lifting job of propagating the W3C context across the subsystems, and henceforth making the mainframe platform as observable as your yet another cloud. That's about it today. Thank you very much. Over to you, Todd.
So yeah, thank you, Mac. I mean, that really does conclude what we have, other than I just kind of want to, quick summary of what he just said. It's like you're adding in the traces, you got the logs, the metrics, because you might look at the elapsed time of a hop in your metrics or in your trace, and you'll say, well, there's this number here, but how do I know if that's good or bad? And that's not part of OTel. But if you can add in the metrics associated with those transactions or from different subsystems, then you can really enrich the OTel experience, and it's just shows you everything. So that's kind of the art of what's possible, and I think what's probably going to be coming. But I think that will really round it out and help you. Amanda, back to you.
Thank you. Thanks for all the great information. So I do want to make sure you all know that you can hop off mute or drop some questions into chat as they come up. And while you're thinking about your questions, I'm going to get my slides back up. And I do want to thank Broadcom and Data Kinetics for sponsoring our event today. Sorry, let me just make sure I have everything popped up. I know that at least one of our presenters today shared their PowerPoint presentation or slides with me today, and that is something I would love to publish if all of you have slides or even additional reading that we can provide to the attendees today. It's a great resource that we'd like to pair with our video and transcript from today's session. So I'll move on to our articles and news, and I pulled a couple of recent-ish articles that we've published on CICS from Planet Mainframe, and I think, though, while these are great articles, there's probably more resources coming up and available from the most recent release that happened so recently that we haven't published anything about it yet. So. But here are some QR codes, or you can just search CICS on planetmainframe.com to find these articles. I do want to also mention that any of our videos are posted on YouTube, but also on our site where we post all the recaps and recap articles. We have an open call for contributors on Planet Mainframe. You can use the QR code or just go to planetmainframe.com and find it there. And I'll also do a plug. Usually I do a plug for our job board at jobs.planetmainframe.com, but I didn't include that today, but I want to just go ahead and mention that because we've seen a big uptick in job postings lately. So I think some people are starting to make some moves, and I want to just put that out there as a resource for you as a job seeker or even someone who's hiring. So take a look at that. And our next meeting is going to be, I just closed out my November 13th. Sorry. Here's that slide. November 13th is when our next meeting will be. Speaker to be announced, but you're probably on our mailing list and we'll be able to get that announcement soon. And if you're not on the mailing list, I'm going to make sure you're added today. So don't worry, you can't escape the news and information that quickly. So with that, does anyone have any questions or last comments they want to share?
So the only thing I'd say, thank you all for coming along today. This open telemetry space is fast moving. There's more to come. Stay close to us. We'll be back with more news hopefully soon.
And I did just get a question into my private chat, my private message. If y'all can, I'll drop it in the regular chat. Yeah, while y'all reading that, thank y'all for participating. Like I said, it's always nice to get such a plethora of information in one session.
So the question, is there an option to turn on the hotel trace and off? If so, who would have control over it? So today that's by subsystem. So we've mentioned 4 subsystems in play. Mark talked about SIP parameters and how we use that in CICS. MQ and IMS and DV2 have similar simple mechanisms. As we go forward, we will be looking at perhaps a more consistent way to tackle that. But again, that's one of those things that it's worth staying close to us on. So simple, we believe today, done through the standard admin interfaces or mechanisms for the subsystems. But yeah, watch this space.
Last call for questions. Thank you, Shruti. All right. Well, I want to thank you, Mark, Dave, Todd, Max. Thank you for presenting with us today.
No problem at all. Great to talk to you all.
Yeah.
All right.
Thank
Have
you.
a good one.
Thank you very much. Thanks, everyone.